Welcome to the ARGH Project's presentation. The ARGH Project is an industrial vision camera system for large commercial and military drones in collaboration with Collins Aerospace.
The system includes two industry vision cameras with monocoms and integrate via Kiki version and USB version with an NVIDIA Jackson ARGH serial platform for processing.
The system is fully autonomous and requires no human interaction after it starts up. We've also included a user interface with push-button interaction to allow the user to set personalized settings based on what they desire from the flight recording.
Our team has been able to integrate different industrial vision cameras with different proprietary libraries into one single program, supporting IMPREX KE protocols as well as FLIR USB protocols. We are also able to optimize our e-paper display to refresh with a 75% improvement at the rate of 2 seconds instead of the original 8 seconds provided by the library.
During the design phase of our project, we have 7 changes of a project from an optical video recorder to industrial reach version recorders. Our team is able to make a quick change to our design, proceed with the new project with reasonable distribution, and eventually catch up to our deadlines.
The most challenging area of this project was system integration. While it was quite an accomplishment to get each block working individually on its own, it was a whole nother beast entirely to get them all working together. It took us over 90 hours of lab time to connect all our parts into one cohesive project. Even now, if we were to go back and do more future development, we do need to improve slightly upon the ability to boot immediately and run consistently. It all runs very smoothly though when it runs manually on its own. Our system all set up and running. Right now it's counting down a preset delay time, and once it hits 0, we should see both cameras start recording. We also have our solid state drive on screen here, so we'll see folders for each camera appear once they do start recording. You see that camera 1 and camera 2 both have folders now. The thermal camera shows on screen automatically so that we can see ourselves. And you'll notice that it's counting down how long it's going to be recording. We have this user interface attached so that we can press buttons to do different things. This one lets us select between different options, which would allow us to add a preset delay or record time from here so that the screen is not required. This previous settings button would send things back to a previous choice. If I press select, we should see that one activate. There we go. And now we've just set it to a minute for each. So we'll notice that the cameras are not on anymore because we've stopped recording and we're doing a minute preset delay again. And if we go into the folders on here, we will see that we have images at 60 frames per second for both cameras. This is the thermal camera here. And then on the other side, we have the IMPREX camera. These are stored with relative timestamps so that they can essentially be synced with each other. So 1.840 will be directly correlated to an image taken at the same time on the other camera. And here in 8 seconds we will see it's going to start recording again, and both cameras should begin again. There we go, we have the thermal camera back on screen, and in these folders they will be saved with different flight times. The system stores these variables as well, so that if the system were to lose power and start it up again, it would immediately start recording with 45 seconds since these are saved in files. At the end of this project, we think we've achieved quite a lot and we're pretty proud with how it turned out. I think our biggest achievement was getting all of our pieces working together as one. Getting all the pieces to fork and thread simultaneously without breaking anything was quite a challenge, and I'm really glad that it ended up working at the end. For future development, we need to work mostly with autonomous function. We did have some issues with the program starting as soon as the Jetson starts up. We really need to figure out how to get pieces to mount to it and how to get pieces to run consistently on startup, as some of them don't run every time. This would be crucial for it to actually be able to be implemented on a drone, as we want to limit human interaction as much as possible. We do think the project is almost all the way there though. We may look into using FSTab to work better with our solid-state drive, and that would be an option for the future.